Hello everyone, welcome to my YouTube video. This is Dr. Song. I want to explain about the quantitative research method regarding to the type 1 and type 2 error and also the relation with the power. In fact, we are concentrating on understanding the theoretical level of the quantitative research method. So it's very important to perform the analysis test, but also I think the theoretical level should be well understood so that you can really understand the basic concepts of the quantitative research method. And then when you will perform your analysis, then you can decide if you will accept your null hypothesis or you are failed to accept your null hypothesis. So these things are like very like a theoretical level, but also that is the really the basis of your understanding of quantitative research method. So I think it's important. So this time I collected some different materials from the different courses. So that can be sometimes in the French also, but they are not far away from the what I'm explaining in English also. So I think that you can just follow what I present about this concept of type 1 error, type 2 error, and then the relation to the power. So these are the courses I incorporated the content from the three courses in the University of Ottawa. So you can take a reference from these courses. So the errors in hypothesis testing. There are a lot of resources you can find in the internet explaining about the type 1 error and type 2 error. But in fact, because of the confusion, many students they just pass the understanding this level. So this time we can take a look more with the more details and also with the slow speed. So you can really understand what that one wants to say. So researchers use the inferential statistics. So that means that like a correlation, regression, ANOVA test, etc. We will perform with the SPSS. So we call these things the inferential statistic to estimate the population's parameters by studying the statistics of a sample that is supposed to represent that population. So you know that we cannot test the whole population. That is almost impossible and an idea. So we take the sample and then we will see the possibility to estimate about the effect of the in reality with the population. So this is a quantitative research method. So the accuracy of conclusions about the relationship between the independent and dependent variable may be affected by the two possible errors, type 1 and type 2 error. Okay, so I already explained that we have to see the p-value. After inferential statistic, p-value will be obtained. In the no matter how no matter how the statistic analysis, you will obtain the p-value. So let's say the p-value is less than 0.05, and then we will reject our null hypothesis because there is a significant difference, and then that is the result of your analysis. But however, when even though you obtain the p-value is less than 0.05, it can be always the error. So type 1 error means that even though your alpha is less than point 0.05, so I will write here, is p-value is less than 0.05, yeah, so that means that you will accept your alternative hypothesis and the null hypothesis will be rejected. However, this is the error. That means that type 1 error is really we don't want to have, even though you obtain the p is less than 0.5, but this is not correct. So in fact, we have to accept the null hypothesis. So this we call the type 1 error. Now, type 2 error. The null hypothesis is false. Type 2 error occurs when the null hypothesis should be rejected. So this is the when you obtain the p is greater than the 0.5, and then you accept your null hypothesis, but null hypothesis is a false, means that we should not accept null hypothesis because this result is significant. So we call that is a type 2 error. So now you can imagine what kind of error researchers prefer. Of course, we prefer the type 2 error because the research we do, in fact, that is significant, but the p-value is greater. So we are like we decided in a wrong way, and then we accept the null hypothesis, but in fact the research was insignificant. So because of that, researchers prefer this error. Type 1, type 2 error again. So I will show you the many different slides, but they are talking about almost the same thing. Type 1 error occurs when we believe that there is a genuine effect in our population when the fact is not. In fact, is not. But you will consider that that is a effect. So to avoid this kind of error, especially in the medication sector, they put the p-value is very, very small. P is less than 0.0001 instead of the 0.05. This is in the conventional way of the p-value. But in the medication sector, because we don't want the second effect of our medication, which is created, so we put the p less than 0.0001. So if your p-value is not less than this, and then you will reject your alternative, and then you will accept your null hypothesis. So there is no effect. So this is the case how you will apply type 1 error. Type 2 error. Of course, when we believe that there is no effect in the population, but in fact there is an effect. So even though your p-value is less than is a greater, sorry, is a greater than 0.05 here. So is a greater than uh okay, so it's a greater than 0.05. So you say, oh, there is no significant effect. So we will accept our null hypothesis. We will reject our alternative hypothesis. However, that is an error. Why? Because the 0.05 is very rigorous for certain sectors. So, for instance, experimental study. Experimental study is very difficult to obtain. The p-value is less than 0.05. So in that case, you will adjust your p-value. It is the zero point 0.1. Instead of the 0.05, you will make a bit more extended, more generous p-value. So if your p-value is less than 0.1, point 0.1, yeah, and then you will consider there is an effect, effectively. So in the reality, there will be effect. So you will accept your alternative, and then you reject your null hypothesis. So this is about the type 1 and type 2 error. I hope you understood a bit with my explanation. And the next slide is almost the same. So this is, you can see that H1 is a false, and then we consider that is a correct conclusion. So this is the one error. So in fact, the H1, it means H0 means that its null hypothesis was true. So this is about the type 1 error. And then, in fact, the hypothesis, null hypothesis was a false, but we consider that that is a correct conclusion, and then this is a type 2 error. So you can see there are a lot of diagrams that is explaining about the type 1 and type 2 error. But if you are confused with some versions, please find the proper version for you, and then you will just keep and then stick to it to understand that. So this is another type 1 and type 2 error about. So you can see that the null hypothesis is true. And then that is about our error. Type 1 error means that, in fact, we didn't consider that null hypothesis was true. We considered the alternative hypothesis is true. But this is a type 1 error. This is an error because, in fact, there is no effect in real life. And then type 2 error is that, in fact, we rejected our alternative hypothesis, but in fact, in the reality, that is a real the effect in the reality. So we should not reject our alternative hypothesis. But in this case, we can see here when type 2 error is a small, that means that we make the small amount of error with the type 2 error, and the power comes from this. So it's 1 minus beta. Beta is a type 2 error. So if the type 2 error is a small, and then you see the number will be greater. So in that case, that means that the test has the high power. So we consider that that is a power. So you should focus on about this part is this is the power is coming from here. Your analysis power is coming from the when your type 2 error is a small, and then you can have the greater power. Okay, again, another diagram. This is also almost the same. You can see that here, 1 minus beta, that is the power. So that is almost the same diagram like what you saw. Type 1 error is we reject a true null hypothesis. That is the null hypothesis was true, but we reject it. That is an error. And then this is we accept the null hypothesis, but in fact that is not true. There is an effect. So that is a type 2 error. Okay. So you will maybe study a bit about this concept, and then you will follow the one diagram you prefer, and then that is your conceptual understanding. So, two type of error. Type one, rejecting a true null hypothesis. Yeah, that is our error. Type two error, not rejecting the first null hypothesis. So we have to normally reject our null hypothesis. That is type two error. And then, in fact, we have to accept our null hypothesis. That is we didn't do so. That is type one error. So these are the explanation. And then this is another diagram because this is French, but you almost can see the same thing. That is the with another diagram is almost the same thing. So to support the statistical significance of the alternative hypothesis, researchers are interested in the error for rejecting a first null hypothesis. There is beta. Yeah, as I explained that we prefer the type 2 error because in fact our analysis in fact it was significant. So that is our interest. And then if we want to have the higher power is greater than the zero point 0.8, that is the type 2 error should be the small amount, and then we can have the more power. So the power, how you can decide the effect size and the level of significance alpha and the p-value, and then the sample size. So as I explained before, your p-value can be changed according to the sector. If it's a medication sector, p-value should be the very, very, very small. And then in the experimental sector, p-value can be a bit generous. It can be less than zero point 0.0, zero point 0.1. So that is how you can adjust to that. And then effect size and the sample size should be greater. Always the greater sample size has the more power. That is always. And then the effect size, that is about the how much it's real in the real life, how much is applied. So this is about the effect size, and we have a lot of way to calculate the effect size. It depends on your analysis. It can be your correlation, and then there is a Pearson R, and then is your t-test is a Cohen's d, etc. And also ANOVA is a eta. So these different measurement represent the effect size, and the effect size means that how much is the magnitude of the relationship, and then that degree, that is the how much is present in the real life. So we will talk about the effect size next time. But for this class, we were concentrating on to understanding the type 1, type 2 error, and then from where the power of the analysis comes. So thank you so much for listening to my YouTube video today. And then next week, we will talk about the effect size and then statistical power also. Thank you.